Welcome to the deep dive. Just start for a second and think about your digital life. Those shows that just magically appear on Netflix, the music playlists that seem to, read your mind, the stuff that pops up online right when you need it.
Yeah.
Behind all that, quietly shaping things are recommendation systems. They're kind of the unseen architects of so much of our online world.
They really are. Always learning, always changing, suggesting things you might like, maybe even before you know you like them.
Yeah. And today we're doing a massive deep dive into how large language models, LLMs, are just radically transforming these systems. We're talking beyond simple matching now. We're looking at how LLMs let these systems truly understand the content and what users are actually trying to do on a much deeper level. So our mission here is to unpack the key ideas from our source material. We're focusing on three big shifts that are changing how we all discover and interact with information online. The goal: to give you a shortcut to understanding the absolute cutting edge of AI in recommendations and search.
And you'll hear about some pretty surprising ways they're solving really old problems, like the cold start problem, where new items just have no data. And that constant struggle for, high-quality, relevant information. We've got some fascinating real-world examples from companies you definitely use. Think Kuaishou, Indeed, Spotify, Netflix, Etsy.
Okay, let's kick off with the first really big idea.
Yeah.
Something called semantic IDs. Think of it as moving beyond the hash-making recommendations, truly understand content. So what was the core problem our sources pointed out with the traditional way, the old systems?
Well, the big challenge has always been these hash-based item IDs. Just imagine every movie, song, product, it just gets a random unique number, like an ID tag. The thing is, these numbers, they don't inherently tell the system anything about the item's content. It's just an identifier, like a barcode almost.
Right, so it's not just about being unique, it's about the ID itself meaning something. Like if I number all the library books, but the number doesn't tell me if it's sci-fi or a cookbook.
Exactly that. And this leads to some really common headaches. Cold start is the classic one. A brand new movie comes out, a new product appears. It has zero interaction history, so the system's clueless. Who should it recommend this to?
Gotcha.
Then there's data sparsity. Lots of items, especially the niche stuff, the long tail, they just don't get many clicks or views. Hard to learn about them. And finally, these systems tend to get stuck in a popularity bias. They just keep pushing what's already popular.
Making it even harder for new things to get noticed.
Exactly.
So how does semantic IDs fix this? What's the breakthrough?
The semantic idea is to embed the meaning, the essence of the content, right into its ID. Think of embeddings like numerical fingerprints, or maybe like DNA for the item, capturing what a video is about, its visuals, its sound, the text description. It often uses multimodal data pulling from images, audio, text to create this richer ID. It gives the system a much deeper sense of what it's actually recommending.
That makes a lot of sense. And where are we seeing this actually working? Our sources highlight a great case study, Kuaishou, that huge short video platform. What's the immediate challenge you think of with their kind of scale?
Kuaishou, yeah, it's like TikTok. Users are uploading hundreds of millions of short videos every single day. Just the sheer volume of new stuff makes it incredibly hard for a recommendation system to keep up, let alone learn effectively. It's like drinking from a fire hose.
Okay, so how did they handle that fire hose using these semantic IDs?
Their solution was pretty clever. They combined static content embeddings, those fingerprints of the video itself, with dynamic user behavior, like what people watch and like. For the static part, they used specific models. ResNet for visuals, BERT for the video descriptions, VG-GISH for audio.
So really pulling insights from everything in the video, the look, the sound, the words.
Precisely. Then they concatenated, basically stuck all these different embeddings together. From that, they used k-means clustering away to find patterns on a massive 100 million videos to learn just 1,000 cluster IDs. The model then learns to map this rich content space, what the video is using these cluster IDs, to the behavioral space, how people react to it.
Connecting the what to the who likes it.
You got it. What the video is about gets linked to how users interact, watching, liking, sharing.
And did it work? What was the actual impact?
Oh yeah, it worked. These semantic IDs didn't just beat the old hash IDs on standard stuff like clicks and likes. Crucially, they significantly boosted cold start coverage by 3.6%, more new videos getting recommended, and they increased cold start velocity. Those new videos hit view targets much faster. Big wins when your platform depends on fresh content.
And for you, listening, what's the really big takeaway here? Why should you care about semantic IDs?
Well, it's not just about showing new videos. The real breakthrough is how semantic IDs can create this virtuous cycle for new content and creators. It helps break that popularity bias that often stifles discovery online. It means recommendation systems can understand the content now. They could even give you human-readable reasons why you might like something. Imagine Netflix saying, "Hey, we think you'll like this because it's a sci-fi movie with a strong female lead, similar to those other three you watched." It makes recommendations feel less like a black box, more intuitive, more trustworthy.
Okay, that Koaishu example really shows how understanding the content is key. But what about the data feeding these systems? Our second big idea tackles that. LLM augmented data boosting quality and scale in recommendations. Expert, why is getting high-quality data such a persistent challenge here?
Right, well, data is the absolute lifeblood of machine learning, especially for search and recommendations. You need good data and lots of it. But historically, getting that data stuff for query expansion, finding synonyms, fixing typos, it's been super expensive and time-consuming, often relies on lots of human annotators looking at things, a huge bottleneck.
Right, humans labeling things one by one. Slow.
Very. And this is where LLMs are stepping in as a potential solution.
How so?
Well, LLMs are proving to be remarkably good at generating synthetic data and labels. Basically, creating high-quality training data that looks real, has accurate labels, but it's made by the AI. It saves enormous amounts of human effort and cost. It's a potential game changer for scaling data creation.
Let's look at Indeed. That's our first case study here, the job platform. They had a serious issue with bad job recommendations, didn't they? What was really at stake?
Yeah, Indeed was sending out job recommendations by email, but users were often finding them irrelevant, just a poor fit. This created a big trust problem. And critically, it led to people unsubscribing. Once someone unsubscribes from that kind of service, getting them back is, well, it's incredibly hard.
Makes sense. And feedback was tricky.
Very. They had thumbs up, down buttons, but people didn't use them much. That's sparse feedback. And implicit feedback, like someone just not clicking a recommendation, is really vague. Did they hate it? Or were they just busy? You don't know.
So our sources map out this whole iterative journey they went on. Walk us through their attempts.
Yeah, it's a great window into real-world ML development. They started with human-labeled data, getting experts to rate the recs. Then they tried open LLMs like Mistral, Llama 2, but the results were pretty poor, too generic. So they moved up to GPT-4. That worked really well, like 90% precision and recall, great quality, but it was way too slow, 32 seconds to evaluate one recommendation, and too expensive for production scale.
32 seconds. Yeah, definitely not going to work in real time for users.
Yeah. Not even close. So they tried GPT 3.5. Cheaper, faster. But the precision dropped. Only 63% of the recs it flagged as bad were actually bad. That means they're accidentally throwing out 37% of good recommendations. For a job site, that's a huge problem. You can't discard good matches.
Right. Every good match is crucial. So another iteration was needed. What was the breakthrough?
The breakthrough was fine-tuning GPT 3.5, tailoring it specifically for their task. That got the precision up to 0.83, much better. And it was a quarter of GPT-4's cost and latency. Still a bit slow for online use, though about 6.7 seconds.
Better, but still not instant.
Right. So the final step was distillation. They trained a much smaller, lightweight classifier using the labels generated by that fine-tuned GPT 3.5. Essentially, they taught a speedy little model to mimic the judgment of the bigger, smarter, fine-tuned model. That achieved high-performance 0.86 AU ROC, which is a solid metric, and crucially, it was fast. Real-time fast, under 200 milliseconds.
Wow, from 6.7 seconds down to under 200 milliseconds. That's a massive speed up. How do they usually achieve that technically?
It's often a mix of things. Optimizing the model's architecture, making it simpler, using more efficient ways to handle the data, streamlining the whole inference process. But the core idea is simple. Train a small, fast model to copy a big, slow, smart one.
Okay, so what was the payoff? What did this mean for Indeed's users and their business?
The impact was pretty significant. They cut bad recommendations by 20%. And here's the really interesting part. They thought maybe showing fewer recs, even bad ones, might lower application rates. But the opposite happened. Application rates actually went up by 4%, and unsubscribe rates dropped by 5%.
Oh, applications went up even with fewer recommendations. Why do you think that happened?
It's a fascinating result, isn't it? It's not just about accuracy. It suggests that ruthless curation, actively removing the bad stuff, can actually drive more engagement and conversion than just showing more things. It kind of flips the script. Maybe less but better is more powerful in these systems. Users value quality and trust. Indeed showed that focusing there improved their core metrics. People weren't just looking for more jobs, they were looking for better, more relevant ones.
That's a powerful lesson. Okay, let's shift to Spotify, our second LLM augmented data case. They were trying to grow new categories, right? Podcasts, audiobooks.
Yeah.
What was their specific hurdle?
Right. Spotify is obviously huge in music, but they needed to let users know about podcasts and audiobooks without just plastering annoying banners everywhere. They had this category cold start issue. How do you get people to explore completely new types of content on a platform they associate mainly with music?
And how did LLMs help them, specifically with augmenting data?
They built a query recommendation system, so when you search, it suggests related searches. They use conventional methods first, pulling queries from playlist titles, mining search logs, adding modifiers like cover to artist names, standard stuff. But then they used LLMs to augment that. The LLMs generated more natural language queries, adding richness and variety to what they already had.
Ah, so not replacing the old ways, but making them better. How does that look to me as a user?
When you search on Spotify now, you might see these suggested queries at the top of your results. They're often generated or enhanced by LLMs. It's a subtle nudge, informing you about related stuff in podcasts or audiobooks without being intrusive, like podcast about topic you searched, or audiobook version of book title.
Subtle, yeah. And what was the result of this approach?
It led to a 9% increase in what they call exploratory queries. That means nearly 1 in 10 users were actively exploring these new product types daily, just through search. It really shows how LLMs can help generate richer, better data at scale, especially for those less common long-tail searches, and way cheaper and faster than having humans try to think up all those variations. Makes you wonder how much of your online discovery is quietly shaped by this kind of AI data enhancement, right?
Absolutely. Okay, so we've seen LLMs help understand content better and generate better data. But what if you could combine all that intelligence into, like, one central brain serving the entire user journey? That brings us to our final big idea. Unified models streamlining complexity for faster innovation. Expert, what's the organizational mess these unified models are meant to clean up?
Yeah, think about big companies. They often have separate recommendation systems all over the place. One for the homepage, another for product pages, another for the shopping cart, maybe another for the thank you page after you buy something, plus separate systems for search and for ads. Each one is often its own custom-built thing. That means tons of duplicated engineering effort, super high maintenance costs, and critically, if you improve one model, those learnings don't automatically spread to the others. It's just this tangled web of specialized systems that don't really talk to each other effectively.
So unified models are the answer, like foundation models for vision or language, but applied to recommendations.
That's the idea, exactly. Create one, maybe a few, comprehensive models that can handle multiple tasks across the user journey instead of dozens of little specialized ones. The concept isn't brand new, but LLMs are really turbocharging it because they're so good at handling diverse inputs and understanding context.
Netflix comes up again here. Their unicorn system, what specific pain point drove them to unify?
Netflix had exactly that problem. High operational costs, missed chances to learn because they had separate models for search, for similar item recommendations, even for suggesting things before you search. Different teams, different systems. Improvements were siloed.
So what did Unicorn actually do? How do they merge all that?
Unicorn stands for Unified Contextual Ranker. It's designed to understand all the ways you interact with Netflix searching, browsing, what you just watched. It uses a user foundation model based on your watch history and a context and relevance model. The absolute key is a unified input schema. One way to feed data into the model, covering user ID, search query, country, the specific task, and they cleverly fill in missing pieces. Like if you just finish watching something and get recommendations for similar items, there's no search query, right? So they just use the title of what you watched as the input to find similar stuff. One model learning from everything.
One model to rule them all. What was the impact? Did it perform as well as the specialized ones?
Here's the really impressive part. Unicorn was able to match or even beat the performance of the old specialized models across different tasks. Now you might think, okay, just matching, is that a big deal? And yes, it's a huge win. It massively cuts down technical debt, simplifies the whole system, and it creates this powerful innovation multiplier. When you improve the core unified model, that improvement instantly benefits every place it's used. Progress just accelerates across the board.
That's a great way to think about it, the innovation multiplier. Well, okay, last case study, Etsy. They have a unique inventory problem, don't they? All those handmade, one-of-a-kind items.
They really do. Millions of unique items, constantly changing. They needed to help users find things, whether the search was super specific, like Mother's Day gift for grandma who likes gardening, which might only match a few items directly, or really broad. And standard text matching, lexical embeddings often miss the nuance with handcrafted goods or user preferences.
So how did they tackle this with unification? What did their setup look like?
They used a two-tower architecture. Basically, one tower understands the product, the other understands the user's query or intent. Then they compare the two towers efficiently. The product encoder tower uses T5 models for text embeddings from item descriptions. It also learns from logs which products got clicked or bought after specific searches. The other tower, the query encoder, processes the user's search terms. Crucially, both towers share some components for text tokens, product category, even user location, so the system can match users to local sellers, for example.
And how do they bring in personalization and that tricky quality aspect for unique goods?
User preferences, past searches, purchases get encoded too. But here's a really neat trick. Etsy built a quality vector reflecting ratings, how new the item is, conversion rates, right into the product embedding itself. And to make the comparison work, they added a constant version of that quality idea into the query embedding too. It's a smart way to bake quality assessment directly into the matching score.
Very clever. What was the outcome for Etsy? Did it help people find stuff better?
The results were pretty amazing. A 2.6% increase in conversion across the entire site, and over a 5% jump in purchases coming directly from search. It really shows how unified models can simplify things and drive real business results. Improve one tower or the core embedding logic, and everything benefits. Now, there's a slight caveat, sometimes called an alignment tax. Optimizing a single unified model for everything might slightly hurt performance on one specific task while boosting others. So sometimes companies might end up with, say, 2 or 3 unified models instead of just one giant one. To avoid that tax if it becomes significant, it's about finding the right balance.
Okay, wow. So wrapping this up, we've journeyed from understanding the content itself to generating better data to building these more streamlined, unified systems.
Yeah, we've hit on 3 core ideas reshaping recommendations in search. First, semantic IDs moving beyond just labels to actual content meaning. Second, LLM augmented data getting better quality data, faster and cheaper using AI generation. And third, unified models simplifying systems and unlocking that innovation multiplier effect.
And these aren't just abstract tech concepts, are they? We want you, listening, to think about how these shifts behind the curtain are directly touching your digital life every day. They're making your online world more relevant, more efficient, more personalized. And this push for deeper understanding, for smarter, more integrated AI systems, it feels like it's really just getting started. It's already making your digital experience better, one recommendation at a time.